Mass and energy balance for biosystem. Module 3, Foundation of Conservation Principles. Segment 3, Conceptual Framework for Accounting and Conservation Equations. It's me, Lily, from School of Life Sciences and Technology, Institute Technology, Bandung. In the previous segment, we already discussed about the introduction to the conservative law. And for the segment 2, we already discussed about accounting extensive properties in a system. And in this segment, we will discuss about the conceptual framework for accounting and conservation equation. Conceptual framework for accounting and conservation equation. Accounting equations are used to track extensive properties within a system and their movement across system boundaries. Specifically, an accounting equation is a mathematical description of the movement, generation, consumption, and accumulation of an extensive property in a system of interest. Accounting equation also can be written for extensive properties and the rates of those extensive properties that can be counted. The conservation equation is a mathematical description of the movement and accumulation of an extensive property in a system of interest. When an extensive property is conserved, the amount or rate of that extensive property is unchanged in universe. In other words, the total amount of a conserved extensive property in the universe is a constant. For example, the conservation of total mass is the amount of total mass added to a system and is equivalent to the amount of total mass that the system surrounding gave up. In contrast to total mass, species mass is not conserved and should be described using an accounting equation. When a reaction occurs in a system to produce a particular chemical species, the net amount of that species mass increases, both in the system and in the universe. Since there is a net change in the species mass in the universe, the species mass is not conserved. Mathematically, we illustrate both the concept about accounting and conservation in governing equation. For accounting equation, we can write as an input minus output plus generation minus consumption is equal to the accumulation. And for the conservation law equation, the input minus output is equal to accumulation. And the difference between the final and initial amount in the system mathematically described as the accumulation. For a system in which the extensive property is conserved, no generation or consumption occurs. Input and output terms describe exchange of extensive property. The input and output terms capture the exchange or transfer of an extensive property into and out of the system. It describes all exchanges in which the amount of extensive property transferred to or from the system is equal to that loss or gain by the surroundings. And simply, the input includes all extensive property that is added to the system across the system boundary. For the output, the amount of extensive property that is lost by the system across the system boundary. Exchange or transfer of extensive property can occur by several different methods. The first one, an extensive property can be transferred by bulk movement. In this case, an extensive property often as material, is physically transferred or moved across the system boundary. And the second one, an extensive property can be transferred by direct contact. In this case, an extensive property is transferred to or from an object that physically touches the system without the object or any material crossing the system boundary. And for the third, an extensive property can be transferred through non-direct contact. In this case, the system is acted on across a distance. The most frequently applied type of this transfer is a potential field. So now we move to the example about the extensive property that can be transferred by bulk movement. The problem is equal to the example 2.5. During a normal workday, a local bank circulates physical currency as it handles customer deposits and withdrawals. Create a model that describes how much money passes through the bank from 8 a.m. to 5 p.m., assuming that the total money in the bank is unchanged. And also describe what input and output terms may be present in the accounting equation. So, solution for this model, we can decide that the extensive property is dollars, the system is the bank, the system boundary is the physical exterior of the bank, and the input term is all currency deposit that customer make between from 8 a.m. till 5 p.m. And the output term is all currency withdrawals made in the same period. And because the transfer of money across the system boundary occurs through physical withdrawals and deposit of dollar bills, and we can consider this model as the bulk transfer. Generation and consumption terms describe change in the universe. The generation terms describe the quantity of an extensive property that is created by the system. And the consumption term describe the quantity that is used or destroyed within the system. The both terms capture the production and elimination of an extensive property within the system. And there is also a net production or destruction of the specific extensive property in the universe. The accumulation term describes the quantity that has collected in or depleted from the system within the system boundary during the defined time period. In other words, the accumulation term quantifies the net gain or loss of an extensive property within a system. And there is two types of accumulation, a positive accumulation and negative accumulation. For a positive accumulation, it shows the increase of an extensive property in the system. And for negative accumulation, it shows the decrease of an extensive property in the system. The accumulation term can be determined by finding the difference in quantity present in the system between the initial condition and the final condition. The initial condition of a system is the state at the start of the interval, and for the final condition of system is the state at the end. And the accumulation term may also capture the rate at which an extensive property accumulates in a system. And for the next module, we will discuss about the mathematical framework for accounting equation. Until then, I'm Lily from Institute Technology, Bandung.